Okay, Assalamu alaikum. So let's resume our discussion. We were talking about using vectors and matrices and scalars and all these different types of variables in Octave. So let us continue with this with that discussion. So in this particular lecture, we'll build upon whatever we learned in the last one. And first of all, we'll talk about creating vectors that contain that store text. Okay, so you can do that as well. For example, let us create we can create a new variable, or you can reuse an existing variable. So let us create a variable, say what, say n1. So n1 is going to be a variable, and this variable is going to store some text. Okay, so how do you specify text in Octave? If you want to store text in a variable, how do you specify that? So you specify the text as a string, and you can specify a string in two different ways. Like you can say n1 is equal to n1 is assigned this value, and you can specify the string within these double quotes. So right now this is a string with just one character, the space character. Okay, so right now it is a string with just one character, the space character, and you can add more characters as well. So we can say n1 is equal to introduction to computing. So you can create a variable like that. So now n1 is a vector, and n1 will have these string of characters. So this is a string. A string is basically a sequence of characters, okay, multiple characters clubbed together. So each of these characters is going to be stored as an ASCII character. So inside, like Octave will create a variable in your random access memory by the name n1. That variable will store all these characters that we have specified as ASCII character codes. So their ASCII character codes would be stored there. Now, if you look at your workspace window, here you will see a new variable n1 has been created, and its type is character. Okay, and its size is 1 by 25, so it has 25 characters, and that includes these space characters as well. So if you do the counting, you will reach to the count of 25. Okay, and its type is not double, its type is character, so that means I is stored as character. A character data type takes a single byte. Okay, so it is stored in a single byte. A single byte can store a maximum value of 256. So basically the ASCII character code of I will be stored here, capital I, then N, then T, then R. If you right click on this variable, or let us go to variable editor and double click on N1. So N1 is here. So this is N1, and N1 is being shown as, okay, so since it is a variable of type text, that's why like it is shown as a single string. Okay, and you can change it or modify it as a string directly here. Okay, so let us not do that at the moment. Okay, so we can create another string, say n2, and if you want to create a string, you can also specify the string using single quotes. Okay, so you can either use these double quotes or you can use these single quotes. So let us say that this is a string that we created using single quote characters, and a string can contain anything. Like we can write this expression here as 2 plus 5 multiplied by 6 minus 7. Okay, so we said n2 is equal to 2 plus 5 multiplied by 6 minus 7, but we have enclosed it in single quotes. So these single quotes make all the difference. Like we have done similar things before, and in that case the expression was evaluated and its value was stored in n2. But right now, like we've specified that we are not interested in evaluating this expression, but we are rather interested in storing it the way it is. And we do it by making it as a string by turning it into a string. So now it is a string. And how did we specify it? We specified using these single quote characters. Okay, so you can store it as a string. So now n2 is the string. It is not evaluated. If we do something like this, say we say n3, and we remove these single quotes, okay, so now it becomes an arithmetic expression. Now this expression would be evaluated and the result would be stored in n3. Okay, so this is different, and this is different. This here is different. Here n2 is a variable of type what can we say, type character. Okay, so if you look at n2, where is n2? So here is n2. So n2 is of type character. It has 13 characters. Okay, and n3 is a double. N3 is a double. So you should be careful. You should pay attention to n3 is a double. Okay, so just these single quotes made it a string. So when you turn it into a string, it is treated the way it looks. Okay, so it is stored the way, just like the way it looks. Like each character is stored as an individual character. Okay, so you can do something like this as well. You can do, you can create these. What can we say? Vectors of characters, or we use another term for vectors, and that is array in programming. So we call a vector as a one-dimensional array and a matrix as a two-dimensional array. So array is the term that we use for data, multiple instances of the same data type. So if we have 10 integer values, so we can say that we can store it as an integer of integer array. We can store it as an integer array. If we have 30 double values, like 30 double values that store the heights of students in a class, so we can store that those 30 double values as an array, as a one-dimensional array. Okay, so array is also a term that we use, is a term that we mostly use in the context of programming. We don't usually call one-dimensional arrays as vectors or two-dimensional arrays as matrices. But since Octave and MATLAB, these are tools that are specifically designed to work on matrices, so that's why we stick to the terminology of vectors and matrices here. Otherwise, that is not something that we usually say. Okay, so this is how you can create these variables which store strings. This is a string. Okay, introduction to computer. This is a string. So a string is basically an array of characters, multiple characters. So I is a single character, n is a single character. So you combine these characters to create words or strings. Okay. So you can go through this material, and I hope like you'll find it easy to understand. There's nothing difficult about it. Just like any other variable, you can display the string variable like this as well. You can say display n1, so it will display the string n1. You can say display n2, and it will display the string n2, and you can display pretty much any other variable. Okay, so this is the same. Now let me clear the command window and let me introduce you to another command, and that command is the clear command, clear. So what clear command does is it clears the workspace. Right now in the workspace we have plenty of variables. So if you want to clear all of them, if you want to remove all of them from your RAM and free up your RAM, so you can use the clear command. So clear all, you can say clear all. Okay, so clear all will clear all the variables, or you can simply say clear. Okay, so it will clear all the variables. If you want to just specifically clear a specific variable, for example, say we have the vector a, and a is equal to course, it is a string, and we have say vector b, say it is also a string, and it is also a string. So we have these two variables. You just want to clear a specific variable. Say you want to clear b. So you can say clear B. So it will remove B from the workspace. Okay, so from the RAM it will be removed. So if you need to remove some variables, you can use the clear. So now the workspace only has one variable. If you want to remove A as well, so you can say clear A. So A will also be removed. Okay, you just clear the command window. So what's next? Okay, we have gone through this. Then we'll talk about functions, built-in functions. But before that, we need to complete our discussion of vectors and creating vectors, and then creating matrices. Okay. Once we start talking about functions, then we'll talk about all the functions that we need to talk about so far. So the next thing that we need to study is creating vectors by comprehension. Now, what do we mean by that? Okay. So creating vectors by comprehension, like what we mean by it in Octave, uh, you can create vector in using multiple ways. So one way that we have been using is this way. We specify all the elements of a vector. Okay. So for example, we specify all the elements of the vector like this. We say A is a vector with these values 4, -4, 6, 9. So A is a row vector with these elements. And here we specified all the elements of the vector, explicitly specified each and every element of the vector. Okay. Now, in some cases, we can create a vector by knowing the relationship between the different values of that vector. Okay. Say for example, if you remember our lesson or lecture on Microsoft Excel, so there we created the sine plot and cosine plot or something like that. Okay. So say for example, we need to create a plot. We need to create a plot, and we need to create a plot of a sine wave. Okay, we need to create a plot of a sine wave. Now, in order to create a plot of a sine wave, we need to have angles starting from say 0 degrees to 360 degrees, and then we need to find sine of those angles, and then we need to plot those two vectors. Okay, so how can you do something like that? Now, if you look at the angles, all the angles, they have a relationship. Like you can create that vector of angles by exploiting the relationship between these angles. So they basically occur as a sequence starting from 0, then 1, 2, 3, 4, 5, 6, up to 360. So you can create it like this. You can say angles would be a vector starting from 0 and going up until 360. Okay. So you create this vector angles as a range of values. This is the initial value, 0 is the starting value, 360 is the final value. And we did not specify the step size, like from the initial value to the final value, how should the value of angle, like how should it be incremented? We did not specify that. So by default, like if you do not specify any increment value, by default it is taken as 1. So when you press enter, so a vector will be created, angle will be a vector, and it will have these values. The starting value would be 0 and the final value would be 360. Okay, so it has these 361 columns. So all the values have been printed on the screen. It doesn't look very nice or clean, but I wanted to show it to you. So this is the starting value, the first value in the vector angle, and this is the last value in the vector angle. It is a row vector. If you look here in the workspace window, its dimension, its size is 1 by 361. It is a row vector with 361 elements. So 0 to 360. It has all these elements present. So it has 361 elements. Let us clear the command window. Okay. So we have this vector angle now, and we created this vector by comprehension, by understanding the relationship between the elements of individual elements of this vector. Now, since we are talking about angle and sine of these angles, so let us not wait until the introduction of functions. introduction to functions, and let us use the sine function to find this the sine of these angles. Okay, so say for example these are the angles which are stored with us in the vector angle. So the vector angle stores angles from 1 degree to 360 degree, 0 degree to 360 degree. Okay, these are the angles stored in the vector angle. Now we need to find its sine. We need to find the sine of all these angles, the sine of all these 361 different angles, okay, which are stored in the vector angle. So how can you find the sine? So let us create another variable. Okay, let us call it as sine of angles. Okay, this is a vector. This is going to be a vector, and the name of this vector is sine of angles. So we have angle or vector angle, and let us call it as sine of vector angle. Okay, sine of angle. So how can you find the sine of a vector? So again, in Octave it is very easy. You have two different versions of the sine function. One is the simple sine function, sin. It finds the sine of radians when the angle is in radians, so you can use the simple sine function. If the angle is in degrees, so you can use the sine degree function. So we need to find out the sine of the angle. And where is the angle stored? The angle is stored in the vector angle. So when you say sine of angle is equal to sine d angle, so angle is a vector with 361 different angles. Okay, so this function sine d, it will find the sine of each individual angle in this vector, and it will return, or it will create a vector with 361 values, and those 361 values will be the sine of each of these angles. Okay, so if you press enter, so all the values of the sines of the angle that will be printed. If you don't want that, just put a semicolon here, and the sine of all these angles will be calculated, and those sine values will be stored in sine angle variable. You can look at this variable if you go to variable editor. Okay, so let us double click at sine angle. So this is the variable sine angle. Let me close this one. Okay, so here we have sine of 0, then sine of 1 degree, sine of 2 degrees, 3 degrees, 4 degrees, 5 degrees, 6 degrees, 7 degrees, and so on and so forth. So you can go up until sine of 360 degrees. Sine of 360 degrees is 0. Okay, so now you have angle in the vector, angles stored in the vector angle, and the sine of those angles stored in the vector sine angle. Okay, and how did we find the sine of all these angles? By just calling this function sine d, sine of degrees, and we gave it the vector angle, and it returned us a vector of sine values. So the input to the function sine d was a vector, and the output is also a vector. Okay, and this vector is basically the sine value of each of these angles stored in the vector angle. Okay, so let us use the other function that, although it appears here at the very end, but since we started talking about this function, so let us use it at the very beginning. The plot function. You can use the plot function to plot to create plots. Okay, now you can create plots using different ways. So the simplest way is, now in this particular situation we want to create the sine wave. Okay, so in order to create the sine wave, you need to what do you need to do? So we need to plot the angles on the x-axis, and we need to plot their sine values on the y-axis. Okay, so we can do that. And how can we do that? Let's see. So you can simply call the plot function. Okay, now I'm using this term function. Okay, so function is basically pre-written code, pre-written instructions. So in Octave, the creators of Octave, they wrote this function plot. So we can use that code. The people who created Octave, they created these functions: sine d, sine, plot, clear, clear command window, and we can use those functions just by calling those functions by writing their names. So you can use the plot function by writing its name, plot, P-L-O-T. Now, to the plot function, you provide at least two arguments, two input values. One is the values that need to be printed on the x-axis. So on the x-axis, we want the angles, which are stored in the vector angle. And on the y-axis, we want the sine values of those angles, which are stored in the vector sine angle. So when you say plot angle comma sine angle, so on the x-axis you will have the angle values, and on the y-axis you will have the corresponding sine values of those angles. When you press enter, so a figure will be generated, and that figure will have the plot of these two vectors. Okay, for the first time it may take some time, but this is the plot, the sine wave that we just created. Okay. Okay, so let us show the grid lines here. So maybe you'll be able to see some grid lines. Okay, so this is how you can create the sine wave that we created in Excel. This is how you can create in Octave. Okay, now we can plot some other functions here as well. Since we are talking about trigonometric functions, let us create, we can find the cos of these angles as well. So let us store the cos of all these angles in a variable by the name cos angle. How can you find the cos? You need to call the function cos d. If you had the angle in radians, you can simply call the cos function. Okay, cos function. If you have the angle in degrees, if the angle is stored in degrees, so you can call the cos degree function, cos d, and give it the angle vector as input. So it will find the cos of all the values stored in the vector angle and store the result or resulting cos values in another vector called cos angle. Okay, when you press enter, so another vector is created, cos angle. It is a row vector. It has these 361 entries, and these entries, they are basically the values, the cos values of all these angles. Okay, so this is our previous plot, sine. Okay, and here say we want to plot the cosine. Now we want to see the cosine wave. Okay, so we can say plot. On the x-axis we want the angle values, and on the y-axis we want the cosine values. Okay, press enter. When you do that, so on the figure you will now have the cosine wave. Now you can see the cosine wave. The sine wave is gone. Okay, the sine wave is gone. If you want to preserve both these waves, if you want to see like both these waves, for example, you want to say no, I want the cosine, the sine wave as well. So you can plot the sine wave. You can say plot angle sine angle, and the sine wave will be printed, but that will overwrite the cosine wave. If you want to have both these sine and cosine waves here, so what you can do is you can use another function. This function is called the hold function. So you can say hold on. Okay, when you hold on, so now when you print another, plot another curve on this figure, the previous curve will be preserved. It will not like go away. Okay, so right now we have the sine here, and we turned hold on, and now we want to print the cosine wave as well. So when you say plot angle cos angle, so the cosine wave will also be printed. Okay, so right now we have two curves here. We have uh, two curves here. First one is the sine wave, and second one is the cosine wave. Okay, so if you do not plan to plot more curves onto the same figure, then you can say hold off. Okay, so any new plotting that you will do, so it will override the previous plots. Okay, if you want to do any new plotting, so these two plots will be cleared. So I hope you understand creating angles by creating vectors by comprehension. So we started off here. We created this vector angle, and this is how we created it. Okay, this is how we created it. You can here we specified the range, the initial value and the final value, and we did not specify the increment. Okay, so if you do not specify the increment, by default the increment is taken to be 1. Okay, so if you look at this vector, so all these values, they differ by 1 from each other. Okay, so we have 0, 1, 2, 3, 4. So this is the default step size. Now let's see, if you specify some step size. For example, if you say angle starting value 0, step size is 5, and then final value is 360. So now the angle vector, so it's for the first value in this vector would be 0, the second 5, the third 10, then 15, 20, 25, 30, so on and so forth. So if you press enter, so now you can see angle has fewer values. Previously it had 361 values, now it has 73 values. And all these values, they have a difference of 5 between. This is the first value, 0, 5, 10, 15, 20, 25, 30, okay, so on and so forth. So how did we achieve this? By specifying a step size. Okay, if we increase the step size, if we say angle is equal to 0, 10, 360, so the numbers would decrease further. So now angle has 37 values instead of 73 values. Okay, so now it has 37 values. You can find this cos and sine of this angle vector. You can do that. You can say sine angle is equal to sine d, and we can give it angle as the input. Okay, the sine angle, the size of the sine angle will become the same as the size of the angle vector. Similarly, cos of angle, we want it to be cos d, and then angle. So the cos angle vector has also been modified, and now it is its size is also 1 by 37. And you can plot these again, like you can plot these. Okay, so right now we have these two plots. So we can plot these again. We can say plot angle, comma. So on the x-axis we'll have angle, on the y-axis we'll have sine angle. Okay, so it will override the previous curve. So there isn't much difference. You cannot notice a lot of difference. It appears to be smooth. Okay, but if you increase the increment size, it will start appearing a bit discontinuous. Do a hold on and then plot the cos as well. Cos as well. Okay, so now we have the sine and cos curves both side by side. Okay, let us try something else. Not something else exactly, but let us recreate the angle vector, this time with an even greater step size. So we start from 0 and the step size is 30 and we end at 360. Okay, so the angles would be 0, 30, 60, 90, 120, 150, 180. Okay, so we have very few angles, 13 angles. Okay, and let us calculate the sine and cosine of these angles. Sine d angle, and then cos d And then when we can plot these, we can say plot plot angle and sine angle. So let's see how the figure looks. We still have hold on. Let me do a hold off. Hold off. Okay, let us plot the sine curve again. So now you can see the sine curve, like it looks a bit discontinuous. There is straight. It's not that continuous. It has these sharp edges right now. Okay, and let us do a hold on now, and let us plot the cos curve as well, cos wave as well. Okay. So now the sine and cosine waves, they appear together, and because of the larger step size, so you can see we have, say, cos value here and then here, and the two values, they are joined together by a straight line. So that's why it's not as smooth as it appeared before. Okay, so now you can see these, you can feel these straight lines. Now there is another way of creating a vector. So this is one way of creating a vector. Uh, it's called creating a vector by comprehension. Okay, so you're basically specifying a range of values. This is your initial value, this is your final value, and this is the increment. So the vector is created starting from this value 0. Then the initial value is added with 30, and then you get the next value, then 30 more is added to that, and you get the next value, and you keep on doing it until you get to 360 or a value greater than 360. Okay, then you stop. Okay, so we can create vectors in another way as well. Okay, how can we do that? So let's see. Let me clear the command window. Let us do a hold off. Okay, and then let us clear the command window once again. Now we are going to create vectors using a function that is called linspace, or linear space function. Okay, so how does this function work? Now this is how this function works. Again, let us stick to the angle example. Say for example, we want to create a vector of angles, and this time we want to create this vector of angles using the function linspace. Now the linspace function, it takes three values as inputs. Okay, so when you want to call a function, this is how you call a function. You write its name, and if you want to provide some input values to that function, so you provide those input values using these parentheses. So the first input value that it needs to have is the initial value. So we want the angle to start from 0, and we want the angle to go to 2 pi. Okay, so 2 times pi. So we want the angle to start from 0. This time we are going to have angles in radians, and we want this angle to stop at 2 pi. Okay, the third input that you specify is how many angle values do you want between 0 and 2 pi. Okay, so if I do not specify any value, so by default we will have 100 values starting from 0 up until 2 pi. We will have 100 values. So the angle would be a vector of 100 values starting from 0 going up until 2 pi. You press enter, and this is what you get. Okay, so if you see columns 1 through 6, these are column number 1 through 6, and here you have 97 through 100. So we have a row vector with 100 columns. So angle is a row vector with 100 columns. Okay, why 100 columns? Because the linspace function by default, it creates a row vector with 100 columns. If you do not specify the number of columns, it will create a row vector with 100 columns. And this is the initial value of this vector, 0. The final value would be 2 times pi. That would be 6 point something, 6.2832. Okay, so this is how you can create a vector. This is another way of creating a vector. You can do the same things here as well. Like we have the angles available, we want to find the sine of this angle. Now the angle is in radians. So we don't need to call the sine degree function. We can straight away use the sine function. Okay, so the sine function will find us the sine of this angle vector, all the angles stored in the angle vector. Okay. Similarly, we can find out the cos angle using all these values. So since the angle is already in radians, so you need to simply invoke or call the cos function. You do not need to use or invoke the cos d function. Okay. So this will give us the cos of all those values, and again you can plot this function. You can plot this function. How can you plot it? Very simple. You just need to use the plot command. So you can say plot angle and then sine angle. Okay. So we will have the sine curve here. So we have the sine curve here, and if you look at the x-axis, so now the angle does not change from 0 to 360, but it changes from 0 to 6 point something, which is 2 pi. Okay. And similarly, let us turn the hold on and then plot the cos wave as well. Angle comma cos angle, and we will have both these waves together on a single figure. Okay, so let us do a hold off, so that if we want to do another plot, the previous plots are basically erased. Okay, let me clear this thing. Now let us reuse the linspace function to create a vector of angles, and we want the vector of angles to start from, say, 0, go up until, say for example, 2 pi. That will print one cycle. We want to have 2 cycles, so we need to go to 4 pi. Okay, 4 times pi. And let's say we don't want a lot of points, we just want say 50 points. Okay, so now this function linspace, it will create a vector of values that start from 0, go up until 4 times pi, that is around 13 point something, and this vector of values will have a total number of value. The size of this vector angle would be 50. Here we specified 50. Okay, when you press enter, so you'll see angle is a row vector with 50 columns. The starting value is 0, and the final value is let's see, the final value would be 13 point something, I guess. Okay, so let's see the 50th value, which is, sorry, 12 point something, 12.566. Okay, so the first value is 0 and the 50th value is 12.5 something. Okay, this is how the linspace function works. Now let us find the sine of these angles. How do you find the sine? Sine angle is equal to sine of angle. Since the angle is in radians, we don't need to use the sine d function. Similarly, we can find the cos of it as like this, cos of angle. Okay, and we can do the plotting. We can plot the sine wave. On the x-axis we want the angle, on the y-axis we want the sine values. Okay, then we can do a hold on, and then we can add the plot, the cosine wave. Okay, let's see, what do we get? So now we have 2 cycles. Now we have 2 cycles. Okay, 2 cycles of both the sine and cosine wave. 2 cycles of both the sine and cosine wave. Okay, and this time we created these vectors using the linspace function, Okay, so let's get back to here. Let's get back here. So we learned how to create vectors by comprehension. There you specify a range, the initial value, the final value, and the step size. The step size is in between. And we also created vectors using the linspace function. Okay, we did that. Acha. Next, we also use the plot function, and along with the plot function, we also use the hold on and hold off commands or functions. Okay, and we use these mathematical functions that are available to us in Octave. We use the sine function, which calculates the sine of angle in radians. We use the sine d function, which calculates the sine of an angle in degrees. We use the cos function, the cos d functions. Similarly, you can use the tangent function, to find the tangent of angle in degrees, the cotangent function to find the cotangent in degrees, the arc sine function, in degrees, and all these things. You can use these things, okay? If we have time, we'll come back to it. Okay. Now, let us go to the next very important topic, that is creating vectors and matrices by merging or augmenting existing vectors or matrices. Okay. Let's see how we can do that. Let us get rid of this figure. Let me close it. Let us come here. Let us clear the command window and let us clear the workspace. Okay, so we want to clear all these variables. We want to start with a clean slate. Okay. So what are we going to do here? Let's start with a very simple scalar. Let's say this is we have a, and a is a scalar, and its value is say 5. Okay. Now if you want to create a vector, say v, so what do? This is one way of creating a vector. You can specify the values, individual values directly. Okay. This is what we have been doing. We also did create a vector by comprehension, and by specifying a range and step size. We created a vector using the linspace function by specifying the range and the number of elements that we want to have in that vector. Okay. Okay. The other way was that you can create a vector by specifying all the values explicitly. For example, if you want to have a vector with these values 0, 1, 4, 7. So you can create a vector like this. Okay. We specified all the values explicitly. Okay. Next, for example, you can do this way as well. We can create vector like this. We already have this scalar a. Okay. We already have a. The value of a is 5. So you can say a minus 1. Okay. A plus 1. So we are creating a vector by augmenting this scalar value a. Okay. So, and what are we specifying here? We are specifying here a row vector. So a is going to be a row vector, and the first element, the first column in that row vector is a, the second is a minus 1, the third is a plus 1. Say the fourth is a multiplied by 2, the fifth is a raised to the power 2. Okay, so these are all possible things that you can do. Okay, so now v is a minus 1 4, a plus 1 6, 2 times a 10, and a square 25. Okay, so you can do this. So we created a row vector like this. Similarly, you can create a column vector like this. You can say, and let us make it say v2. Okay, so v2 is, or let us call it c, a column vector. Okay, so we should have called it r. In any case, no problem. So this is a column vector cv. Okay, column vector. So a, then a semicolon, a minus 1, a semicolon, a plus 1, semicolon, then a multiplied by 2. So now we are going to create a column vector 5, 4, 6, 10, 25. So we have created a column vector. Okay. So we have row vector and we have column vector. Let us make v as a row vector. Let us say rv is equal to v. So we are creating a row vector and we are assigning the value of v to it. Okay, and let us remove v. We don't want v. Okay, so now we have row vector, column vector. Understand? Okay, let me clear the command window. So we have a row vector RV and we have a column vector CV. We can create a matrix. Okay. How can we create a matrix? We can create a matrix by using the existing row vector. So we can have multiple row vectors. Okay. Say for example, I want to create the matrix M1, and M1 will have row vector. First, I specify a row vector, then another row vector, then another row vector. So the first row vector is going to be RV. Okay. Then I want say for example 2 times RV minus 1 as the next row. Okay, if you see I'm putting a semicolon here, and if you remember, semicolon basically it tells the octave interpreter that we want to insert a new row vector. So this is the first row vector. Inside a matrix, you can view a matrix as a combination of column vectors or a combination of row vectors. Okay, so row vector on top of row vectors on top of each other, or column vectors next to each other. Okay, so this is the first row vector, this is the second row vector, and similarly we can have the third row vector. We can have, for example, the third row vector can be 3 times RV plus or minus 20. Okay, so how would M1 be created? So the first row would be RV exactly as it is. The second would be 2 times RV minus 1. So 2 would be multiplied with each element of RV, and then 1 would be subtracted from each element of RV. The product of 2 and each element of RV, then 1 would be subtracted from that. And similarly, first each element of RV would be multiplied by 3, then 20 would be, like this operation is going to be applied to each element of RV. If you press enter, this is what you're going to get. So M1 is going to be a matrix. The first row is RV, just like we specified. This is 2 times RV minus 1. Okay, so you can do the calculations, like say 2 times 25 is 50, 50 minus 1 is 49. And then 3 times RV minus 20. So 25 threes are, say for example, 75 minus 20 is 55. So you can verify, do these calculations for all these elements. Okay, so this is how you can create a matrix from existing row vectors. Now we have a column vector as well, CV. So we can create another matrix from this column vector. Okay, how can we do that? So let me clear the command window, then let us print CV, and say we want to create a matrix M2 using this column vector. How can we do that? So we want to have the first column vector, and then we want another column vector next to it. Okay, so there is a space character, there is no semicolon. Okay, because these are columns next to each other. So when you specify a new column, a space character or a comma character is enough. If you want to have a new row, so you have to use that semicolon character. Okay, so this is CV. So next, say we want to have for example 2 times CV minus 10, and then we want to have 3 times CV minus 20, and say we want to have a fourth column as well, which is 4 times CV minus 30. Okay, so now we are going to create a matrix M2, and M2 will have 4 column vectors. First CV, then this column vector 2 times CV minus 10, then this column vector, and then this column vector. When you press enter, so this is exactly what you're going to get. So this is CV. This is 2 times of this minus 10. So 2 5s are 10, minus 10 0, 2 4s are 8, minus 10 minus 2, 12, minus 10 2, 20 minus 10, similarly 50 minus 10 40. So you can verify these calculations for the other columns as well. For example, third column is generated using this expression. Okay, so you can create matrices and vectors using existing values, using existing using existing vectors that you might have. Okay, so you can do that. So I hope like this is clear to you. What else were we going to do? Let me see. Okay, creating vectors and matrices by merging or augmenting. So basically we augmented multiple vectors to create matrices. You can create, like, you can merge matrices with matrices as well. We can do that as well. So say for example, let us see CLC, clear command window. This is how M1 looks like. M1 is basically 3 by 3 rows by 5 columns, and this is how M2 looks like. So M2 has 1, 2, 3, 4, 5, 5 rows uh, and 4 columns. Okay, so again they are not compatible for even for merging. They are not compatible. But say let us clear the command window. This is M1. Okay, so we can create M3, another matrix, and we can create M3 by putting M1 on top of say M1. Okay, so we can have M1 and then followed by M1. How would that look? So we want M1 and below that a copy of M1. Okay, so we can have M1 and M1. So this will place M1 and then M1 on top of M1. So M3 will be something like this. Okay, so we have M1 and then below it M1 again. Okay, if you don't like it this way, you can have M1 and then 2 times M1 minus 10. Okay, so each element of M1 would be multiplied by 2 and then 10 would be subtracted from it. So on top you will have M1 and then below that you will have this modified form of M1. Okay, so you can like use existing matrices as well to create new matrices. So if you want to place them on top of each other, you use this semicolon. If you don't want that, if you want to augment them side by side, so you can do something like this. You can say M1, M3 is equal to M1 and then space 2 times M1 minus 10. So you will have then, so now you will have more columns. Okay, in the previous case the number of rows increases, here the number of columns will increase. So now you have 10 columns. Okay, so this is M1 and this is 2 times M1 minus 10 put next to each other. Okay, so you can create new matrices like this as well. Okay, so I hope like you have understood these things. Okay. Okay, similarly, we have other functions, very useful functions in MATLAB and Octave that allow us to create special vectors and matrices. For example, we can create a function, a matrix that has all ones. Okay, so say for example, we can create a vector or matrix B, and we can call a function ones. The ones function will create a matrix or a vector that contains all ones. What you need to specify here is the order. Like, for example, if you want to create a 4 by 4 matrix of all ones, so you can say 4 by 4 here. So you will have a 4 by 4 matrix of all ones. Or for example, if you want to create a row vector with all ones, so you can do that. Or if you want to have a column vector of all ones, you can do that as well. Similarly, if you want to have a rectangular matrix of all ones, you can do that as well, 2 rows and 4 columns. And similarly, like, you can have some operations applied to this as well. Like you can have b all ones multiplied by 2 plus 1, say. So all the elements will be multiplied by 2 and then 1 would be added. You could simply multiply it with 3 in this particular case. Like the same, you will get the same thing when you do it this way. So the function, the built-in octave function, once it allows you to create a vector with all ones. You might need such vectors or vectors like these in some specific cases. Okay. So at times in programming, you need to have some data available to you. So you need functions that help you create vectors or matrices with dummy data. Okay, so this is one such function. Then we have a function zeros. So you can have a vector, say b is equal to you can have b as a vector or matrix with all zeros. So what do you provide as input to the zeros function? So you provide the order, like what kind of matrix or vector do you want? Say for example, if you want a matrix of order 4 by 5, so it will create a matrix of order 4 by 5 containing all zeros. Okay, containing all zeros. If you want a row vector, so you can specify that you want a row vector of all zeros. If you want a column vector, you can specify that as well, that you want a column vector. Okay, and then of course you can add different values to it. Say for example, you can add say 3 to it. So now you will have a column vector with all threes. Okay, so you can do something like that. Similarly, we have another function that allows us to create a diagonal matrix. Okay, in fact, the identity matrix. You can create the identity matrix of any order, and you can also create a diagonal matrix. Okay, by multiplying the identity matrix with some value. So, in order to create an identity matrix, you call the function I. So identity, if you remember, the symbol for identity matrix is I, capital I, okay? And you add a subscript there, IN. So IN is basically an identity matrix of order n. So identity matrices are basically square matrices, okay? So here you also need to specify just n, the value of n. So if you say I3, so it will create an identity matrix of order 3. Okay, so B is a diagonal matrix of order 3. If you multiply it with a certain value, so on the diagonal you will have that value. Now it would no longer be an identity matrix, it would be a diagonal matrix with uh, identical values at the diagonal. Okay, so you can create any identity matrix of any order. You just need to specify one value. So the n value of n, so the number of rows and columns are equal. So you will get that. So this is an identity matrix of order 6. So you may need to create these identity matrices when you are working with matrices and when you're doing trying to find those solutions of linear systems and all that. So these functions allow you to create those matrices very easily. Apart from that, we have some other very useful functions. These functions allow you to create matrices with random values, matrices with or vectors with random values. So say for example the rand function, RAND. So we can use the rand function to generate random values. We can create a vector with random values. We can create a matrix with random values. Now, what are random values? So random values are random values, okay? So they are not generated by some formula or something like that. They can be anything. So say, for example, let us create a vector of random values. Let us say we want to create a row vector with random values. So you can call the rand function. Rand function is a shortcut for say random. So the rand function will select random values between 0 and 1, okay? So between 0 and 1, theoretically, we have infinite values, okay? Infinite number of real values between 0 and 1. So any of those values can be chosen randomly with equal probability. So you can call the rand function and you can ask the rand function that you want a row vector of 4 values, um, and those 4 values should be random values. Okay, so you can do that. Each time you call this random function, you will have different values. Okay, each time you call it, you will have different values. That is why it is called random value. These values are called random values, and these values are chosen between 0 and 1. Okay, so it can be 0, 1, or anything in between. And these values, they have equal probability of selection. So each value between 0 and 1 can be chosen with equal probability. Okay, so we call this as a uniform distribution. These random values are selected from a uniform distribution. Now, a uniform distribution is a distribution where each value has equal chance of being selected. Okay, so that is a uniform distribution. You can create a matrix of random values. So let us create a matrix 5 by 5, say, and each of those 5 by 5, each value of this 5 by 5 matrix would be a random value. If you call it again, you will have a different matrix. If you call it again, you will have a different matrix altogether. Okay, so random values are also very important. Computers, they are mostly used for simulation purposes. Okay, and in simulation purposes, random numbers are very widely used. So say for example, if you look at some of the videos in this playlist in which I keep on uploading these lecture videos, so there we use these random the rand function to generate random values, and we use this function to simulate different phenomena. For example, you can simulate a coin toss using these random values, and you can simulate the throw of a die using these random values. Okay, so a die is basically a checker. If you have played Ludo, so there you roll a die, and one of the possible outcomes, 1 to 6, like that comes, and based upon that you do something. Similarly, when you toss a coin, so if the coin is a fair coin, so you'll get either heads or tails with equal probability. Okay, so you can simulate the outcome of a coin toss. Similarly, you can simulate the outcome of a die roll. So you can do all these things using the rand function. Okay, this rand function, it generates these random values by selecting any value between 0 and 1, and any value can be selected with equal probability. Every value has equal chances of being selected. Okay, so this is how we can generate a matrix or a vector with random values. Similarly, we have other versions of the rand function. So one of the other version of rand function is the randn function. So the randn function generates random values by selecting values randomly from a normal distribution. Okay, so what is a normal distribution? So a normal distribution is a distribution which looks like, if you plot this distribution, so its curve would look like a bell curve. Okay, so let us do that. Let us, since we talked about normal and uniform distribution, so let us do that. So let us first create these vectors. So let's say we want to create a random vector, and the random vector will have, it will be, say, a row vector with 10,000 values. Okay, so we want to create a row vector with 10,000 random values, and the random values will be generated using the rand function from the uniform random distribution. Okay, so now what do we mean by a uniform random distribution? Okay, so let us call the histogram function hist, and let us create a histogram of this vector b. Okay, and let's see how does that histogram looks. How does that histogram look? Okay, so if you create this vector b with 10,000 values, and you create a histogram of B. We did not specify the number of bins for this histogram. You can specify the number of bins as well. Say we want it to be in 100 bins. Okay. 100 is a lot. I guess let's say 20 would also be enough. Say we want to have 20 bins. So if you look at this histogram, so this is basically all these bars in this histogram. They have almost the same height. It's not exactly the same height, but it's almost the same height. Now, what does this histogram say? This histogram says that the random numbers in B, this vector B, it has 10,000 random values. Okay. Now, these random values start from 0 and go up until 1. Now, we have divided this interval between 0 and 1 into 20 bins. Okay. So, between 0 and this point, which is around 0.04, okay, between 0 and 0.04 we have 500 numbers. Similarly, between 0.04 to 0.06, 0.09, we have maybe around 510 or 20 numbers. And similarly, between all these intervals, we almost have similar number of numbers. Okay, so this is why we call it uniform distribution. Like from every interval, the number of numbers that were chosen randomly, that is almost equal. It is not exactly equal, but it's almost equal. That is why we call it random distribution. Okay, sorry, uniform distribution. It is called uniform distribution. All these numbers, these 10,000 numbers that are stored in B, they are random numbers. They are completely different. They have been chosen randomly. But if you create a distribution of these numbers, like if you look at divide the range of these numbers into different intervals, and you see how many numbers are selected from each interval, so you will have this uniform distribution. Okay, so that is why we say that these numbers are generated from a uniform distribution. Now the other function, randn, it generates number from a normal distribution. The normal distribution, if you plot a histogram of the normal distribution, it will look like a bell. It will look like a bell. Okay, the bell icon. It will look like a bell icon. So let's do that. So let us call the randn function, which will generate random numbers from the normal distribution, and let us generate 10,000 values. Okay, and then let us have a histogram of these 10,000 values, and let us have that histogram 20 bins as well. Okay, so the histogram function, when you want to call it, you give it these two inputs. One is the vector for which you want to create the histogram, and the other is the number of bins, the number of intervals in which you want to divide the x-axis. Now if you do that, in this case, this is the curve that you will get. Okay, so this curve is, or this histogram is shaped like a bell. So if you look at its shape, it looks like a bell. Okay, so this is why this random number, like it takes these random values. These are all random values, but these random values are generated using a normal distribution, and this is what a normal distribution is. If you plot a histogram of these random values, you will get a bell curve. Okay, you will get a bell curve. So that is why we call it a normal distribution. And the mean value of the most values that you will get, those values will be close to 0, and the standard deviation of these values, that will be close to 1, I guess. Okay, so they'll be equally spread on both sides of 0, something like that. Okay, then we have another version of the random function. So most of the times you might be interested in generating integer values, random integer values. So for that we have the randi function, random integer function. Okay, now the random integer function, you specify again you specify two things here. One is the order, like the dimension of the vector or matrix that you want to generate using this function, and the other is the range of values. Okay, so say for example we want to generate a matrix of order 4 by 4. Okay, let's see if it works or not. Okay, so we have generated a matrix of order 4 by 4, and it is populated with random values, in random integer values. Let us change the order 4 by 2. Okay, so you didn't get 4 by 2, 4 rows and 2 columns. You got 2 by 2. Okay, so that means this interpretation is not correct. So it generated a square matrix, and here the maximum value was 4. Okay, so the first value that you have, that is the maximum value that you can have, and the second is basically the number of rows and columns. If you specify just one value, let us do it again. Okay, so let us call it again. Say for example we want to generate a square matrix of order 2 by 2 with a maximum value of 100. Okay, so now we have a square matrix of 2 by 2, order 2 by 2, and the maximum value can be 100 in this square matrix. Okay, if you execute it again, you will get another one of the same order, but values within the same range. Okay, okay. Say for example we want to generate a vector. Let us clear the command window. We want to generate a vector of a row vector with 1 row and 100 columns, okay, or 10 columns, and the maximum value in this row we want to have 100, or we are basically say simulating a die roll, so the maximum value is 6, say for example. Okay, let us get rid of it. So now we have a row vector. So the first input that you specify, that is the maximum value that you can have, maximum integer value that you can have. So we specified it to be 6. Okay, perhaps the minimum is 0. Okay, so minimum can be 0, maximum is 6. This is what we specify, and the next two values, they specify the dimension. Okay, the number of rows and columns. If you specify just one value, so the number of rows, and it basically specifies both the number of rows and columns. It will generate a square matrix. For example, let us get rid of this, and now we are going to generate a 4 by 4 matrix with random integer values between 0 and 6. Okay, or between 1 and 6. Okay, if you want to know about some function, like how does that function work, you can always call help. You can say help rand I. Okay, so then you will get help about that function. So Octave will give you help about that function. Okay, so what does it do? This is the help about this particular function. Rand I, so it has these different versions. You can specify a maximum value, return random integers in the range 1 to I maximum. Okay, so the range is, minimum value is 1, maximum value is I max that you specify. If you specify just one value, so you will have, when no arguments are specified, a single random value is generated, and when you specify just one, so it is taken as a square. So let us look at these different versions. When you just say rand I and you specify 10, so one random value would be generated in the range of 1 to 10. Okay, do it again. So one random value would be generated in the range of 1 to 10. Each time you execute it, this is what's going to happen. Okay, when you specify two arguments, when you say rand I, say for example 10 and then 5, so now a square matrix of order 5 by 5 would be generated with random integer values starting from 1 up until 10. Okay, so here you can see a square matrix of order 5 by 5 has been generated with random values starting from 1 up until 10. Okay. Okay, so let's see, say for example, now we want to generate a matrix of particular or a vector of our choice. Say we want to generate a row vector of a certain order and with values in a certain range, say 1 to 6. We want values to be generated randomly in the range 1 to 6, and we want the values to be stored in a row vector of order 1 by 100. So this is how you can do it. Okay, so these are random values in the range of 1 to 6, and these values are stored in a vector of order 1 by 100. Similarly, you can generate matrices, say 10 by 10, a matrix of order 10 by 10 with random integer values in the range 1 to 6. You can do that as well. So this is a matrix of order 10 by 10 with random integer values in the range of 1 to 6. You can customize the range. If you want to say, no, I don't just want to specify the maximum value in the range 1 to 6 or 1 to 8 or 1 to 10, 1 to I max, I want to specify both the maximum and minimum values. So you can do that. So you say we want to generate a vector B with random integer values in the range, which range? -5 to +5. So here we are specifying two values, the range, minimum value, maximum value. And we want these values to be generated in a 10 by 10 matrix. Okay, so now we want to have a 10 by 10 matrix, and the matrix will have random values in the range -5 to 5. Okay, so now you have this random matrix, 10 by 10 matrix, that is populated with random values in the range of -5 to 5. This can be a vector. Okay, this can be a vector, say 1 by 1000 order. So you can have this vector, so it has 1000 columns. Okay, and all these random values are in the range -5 to +5. So these are very useful functions. These functions that we talked about, the rand function, the randn function, the randi function. The rand function generates random values in the range 0 to 1. All those values have a uniform distribution, and these random values can be used to populate a vector or matrix of any order, like you can specify the order there. Similarly, the randn function is used to generate vectors or matrices with values that have a normal distribution. And similarly, in the case of randi, you can have a vector. You can generate a vector or matrix with randomly generated integer values in a particular range. You can do that. Okay, so we have done these things. The next thing that we want to talk about is how do we determine the size of vectors and matrices. So you can do that very easily. For that we have these very useful functions. Let us clear the command window. Okay, let us clear the command window. And let's see, we have a lot of variables. You can see the variables here in the workspace window. We have a function as well, whose. So it basically prints all the variables. Okay, so we have variable a, what is its size, how many bytes does it take in the if you want to know all about all the variables in the current scope, so you can use this function whose. Okay, so every variable, the size of that variable, and it's the memory that it is occupying in RAM, its type, so all this information is available to you. So right now we are using, say, 9408 bytes. So you can find out the size of these variables using other functions. For example, we have a, so you can find out what is the length of a. Length of a. So a is a scalar, its length is going to be 1. You can also find about the size of a. Okay, size would return you the number of rows and columns. So size would always return you two values: how many number of rows and how many number of columns. If you have a two-dimensional array or matrix, if the number of dimension is more than 2, so then you will have a vector with as many entries as the number of dimensions. Okay, so right now this scalar a, it has one row and one column, so you get this information. If you just call the length, so it will give you the length or size of the first dimension, I guess. This is what it does. The first, like, it will give you the number of uh, or the size of the highest dimension, I guess. This is the size of a highest dimension. So say for example we have b is a row vector. Do we have a column vector here or not? Yes, we have a column vector cv. Okay, so say for example we have rv is a row vector and cv is a column vector. Okay, so if you call the length function for the row vector rv, so it will return you 5. Okay, 5 is the value of the highest dimension. If you call the same function length for the column vector cv, it will also give you 5. Okay, so cv, that is the number of rows in cv. Okay, the size function will return different vectors for both these vectors. So if you say size of rv, you will get 1 5, a vector with two entries 1 5. If you get size of cv, so you will get a vector 5 by 1. Okay, let's see, we have this matrix M3. Say we say length M3. So as per our understanding, it should return 10. Okay, so it returns the value of the highest dimension. So size of, if you look at the size of M3, it has these two dimensions, number of rows and number of columns, 3 rows and 10 columns. So when you call length for M3, so it will return the size of the highest dimension. Okay, let's look at M2. So M2, if you say size of M2, call the size function for M2, it will return the number of rows and columns, 5 4. If you say length of M2, so it will return you the number of rows, 5. Why? Because 5 is greater than 4. Okay, in this case it returned as 10. In the case of M3, it returned as the number of columns 10. Why? Because that was the greater number. So you can use both the length function and the size function to determine the size of to find out the size of a matrix or a vector. Size is a more elaborate or detailed function. It returns you the size of each dimension. Okay, if it has rows and columns, so it will return you the size, the number of rows and columns, both the number of rows and columns, whether the value is a scalar, a vector, or a matrix, or whatever it is. The length, it only returns us a scalar value, just one value. Which value? You can use the length function with a scalar, you can use it with a vector, you can use it with a matrix. It will always return you the value of the highest dimension. So if there are more rows than columns, it will return you the number of rows. If there are more columns than rows in a certain matrix, it will return you the number of columns. Okay, that is what it does. So you can use these functions to find out the size of any dimension of a matrix. Okay, so we have talked about these functions. We have used these functions as well. We use the plot function as well. In addition to these functions, we have other functions. For example, we have these very useful functions, decimal to binary and binary to decimal, and all these functions which you can use to verify the answers to your homework number 1. Okay, say for example, Okay, so say if you have a decimal number and you want to convert it into binary, so you can use the decimal to binary function. Again, you can do it by yourself, but let me do it for you. Say for example, we have 127. So it is a decimal number, we want to convert it into binary. So this is what we get. Say we want to convert this binary number to decimal and see if we get the same thing or not. So if you want to convert a binary number to decimal, so you have to call the binary to decimal function. But if you specify the binary number just like this, it is 111 and then 4 ones, 6 ones, 7 ones. So it will give you an error. Why? Because this would be treated as a decimal number. In order to specify a binary number, you need to specify it as a string. So it has to be a string. So you need to use these single quote characters. Now it will be treated as a binary number. Okay. So now when it is converted, you'll get 127 back. Okay. So you can change it, like if we subtract 1, this is 126. This is say 125. This is say, this is I guess 31. Yes, it is. This is 15. This is 14. Okay. Yes, it is. Now we have other functions that can be used, like we have decimal to hex and hex to decimal. So we have decimal to hex. Say for example, we have a decimal number 255 or 250. Yes, 255. So 255 in hexadecimal is FF hex. Okay. Similarly, we have you can see 252. It is FC. Similarly, if you want to convert this hexadecimal number to decimal, so you can do that as well. How can you do it? You need to provide or write the hexadecimal number, and again the hexadecimal number must be provided as a string. So say for example, we want to see what is FD equal to. It should be equal to 253. Okay, and what would FB be equal to 251, and FA 250, and F9, this would be 249. Okay, so you can do these conversions using these functions. Similarly, Octave will have a lot of other functions as well, and you can look up those functions, you can learn what those functions do, and you can use those functions in your program. Okay, so we have plenty of functions here. The square root function Sqrt, as the name suggests, it is used to find out the square root. So if you want to find out the square root of what? The square root of say 25. So you can simply call square root 25 and you'll get the square root of 25. Similarly, you can find the square root of say these numbers, 100. Starting from 100, we want to find out the square root of numbers up until say 2000. So I hope you can do that. Yes. So starting from 100, so square root of 100 is 10, square root of 200 is 14 point this, 300 this, 420, 500, 600, 7, 8, 930, 1000, 11, 12, 13, 14, 15, 1600, and then this. Okay. So you can find the square root of a vector, and that vector was generated here through comprehension using this colon operator. Okay. You can do that, and similarly you have these other functions available to you. We have this function exponent, so you want to find the power of this function, anything. For example, we want to find the exponent e raised to the power, I guess that is what it does, e raised to the power 1. Okay, so this is the value of e. E raised to the power 2. Okay, so if you want to find the value of e raised to the power any value, so you can do that. Okay, let's see if we have something like this, e raised to the power 1 to 10. So now you have e raised to power 1, e square, e cube, e raised to power 4, 5, 6, 7, 8, 9, 10. This is e raised to the power 10. So you're specifying exponent as a vector, exponents as a vector. Okay. Similarly, we have the log to the base 10 function, the log function, the natural log function. We have all these functions, the roundup function, the floor and seal functions, floor function and seal function. So these are also interesting functions. For example, let's say we have this value. Say we have a is equal to exponent exp exponent 1. Okay, e raised to the power 1. So this is the value of e. Now, what do these functions do? Floor and seal. Now, floor, as the name suggests, it represents the floor. So think of this real value as lying between two integer values. Okay? So one integer value is 2 and the other is 3. 2 is the largest integer value that is smaller than a, and 3 is the smallest integer value that is bigger than 2 that is bigger than a. So 2 is the floor of this value. 2 is the floor. If it falls, so the highest value that it must fall to, or it can fall to, is 2. Okay, so floor is that value. And C is the smallest value bigger than A. Smallest integer value bigger than A. So that is 3. So you can think of A, which is a real value, you can think of it as lying between this floor and seal. So सीलिंग जो है ना वो छत को कहते हैं, फ्लोर जो है वो आपका फर्श है. सो सीलिंग छत है. सो सीलिंग से मुराद वो इंटीजर वैल्यू सबसे छोटी इंटीजर वैल्यू जो ए से बड़ी है, और फ्लोर्स या फर्श से मुराद वो सबसे बड़ी इंटीजर वैल्यू जो ए से छोटी है. ठीक है. So you can, at times you need these values. These are important things that at times you need to use these functions. So this is what this function means. And similarly, we have roundup function. So roundup function, you can use roundup function. So you can round off a to, say, if we want to round it off to 3 decimal places. So क्या value होगी? What did we do? Invalid call to. Correct usage is round x. Okay, so ये simple, इसको आप round off कर दें. ठीक है जी, round off कर देते हैं. So it rounds off to the nearest integer. ठीक है. So हमारे पास a की value है 2.7. If we round it off to the nearest integer, so nearest integer is 3. ठीक है, that makes sense. If a is equal to, say, 2.49, and then we round it off to the nearest integer, so it will be rounded off to 2. Okay, so okay, I guess this is enough for this lecture, and I hope like we have covered all these topics, and I further hope that you have understood most of it and you will be able to use these things, although I agree that you don't have a lot of time, but I hope like you'll be able to absorb all this information, because that is the only thing that you have to do in these days. Okay, so this will be the end of this lecture.